This is my Chapter 6 reassessment. It says a ball traveling horizontally runs into a horizontal spring whose stiffness is 100 newtons per meter. As the spring is compressed, the ball slows down. If the relaxed length of the spring is 30 centimeters and the spring is compressed until its length is 10 centimeters, how much work does the spring do on the ball? So I drew a picture here of the relaxed spring before the ball runs into it and the compressed spring after the ball runs into it. And you can see it at x equals 0 meters, and I've done the initial state s equals 0 and the final state. I changed it from centimeters to meters and did the final minus initial and got negative 0.2 meters, so that goes as the final length of the compressed spring. So our equation is f of x equals negative k of s times x, and that's the force of along the x-axis equals the negative spring constant times the length of along the x-axis, and we're going to integrate since we have a final and an initial length here. So the work done equals the integral from 0 to negative 0.2 of negative 100 newtons per meter times x of dx. We integrate that and get negative 100 newtons per meter times half of x squared. And then we plug in the 0 and negative 0.2 for x and get negative 100 newtons per meter times half of negative 0.2 squared minus 0 and get negative 2 newtons times meter, which is negative 2 joules, and that will be our work done by the spring on the ball. And we can get a negative work here. That makes sense because as the ball is compressing the spring, the kinetic energy is going to go down. So negative work means that the kinetic energy goes down. So that makes sense.